Concrete extension is kind of the same thing. It starts the same anyway. I mean, we'll make our person's secondary surname, but then in order to hold that person's secondary surname, we have to make a new person name type to hold it, based on the old person name type with the new secondary surname added. And this is the same as before. Then we make a new person name element of this type, and that's fine. That's just the same as before. But if we don't want to use implied substitution groups, and there are development environments in which you can't use substitution groups, well, then we have a problem, because things of person type don't hold our new person name. So that means we have to make a new person type, extending NIEM course person type, and adding our new person name to the new person type. And then we make a new person element. And if that person element is inside of something else, then we have to redefine that enclosing type as well and make yet another new element of that type. And if that type is in something else, then we have to repeat that process again all the way until we hit the root level, which means we may end up redefining a lot of things which aren't really changing in terms of their concept, but we need to redefine them anyways. And that's confusing. So let's take a look at this in schema. So with concrete extension in schema, there's nothing fancy here at all. We've got a new Iberian person name type derived from person name type, adding in the person's secondary surname. That's no problem. We've seen this a million times before. Then we make a new complex type, an Iberian person type, based on the existing person type, and adding in that new person name that we're making. And then at the bottom we have the actual elements. We have the new person of the new Iberian person type, the new element person name of the new Iberian person name type, and then finally the person's secondary surname of person name text type out of the NIEM. So now we're making two types, and we've got three elements we're making. And keep in mind that if that person were inside of something else, then we'd need to redefine that enclosing type as well. So we'd have a third complex type there, and then we'd have to have a fourth element defined. And if there was an enclosing type around that, that would need to undergo the same thing. Then we'd have, what, 4 types being redefined and 5 new elements. And if there was one around that, then we'd have to go through it all again. It chains up very, very quickly to where you can have an awful lot of new elements. So here's what the instance document looks like with concrete extension. We've got a person on the outside, that's the big person object. Inside of there is a person name, inside of there is a given name, surname, and a secondary surname. It looks almost exactly like the substitution group version. The only difference is on the prefixes. If you look carefully at the prefixes, you'll see there's an additional extension. We've got the extended person name, and the extended person secondary surname. 1, 2, 3 extensions. Keep in mind that if there were another enclosing element around the person element, that too would be an extension, so there'd be a 4th. And if there were an enclosing one around that, there would be a 5th. And if there's one around that, there would be a 6th. We just stopped at person because let's just keep it on a slide and keep it reasonable. But the key is this has 3 extensions and potentially many more, as opposed to substitution group methodology, which just has 2 extensions. Now let's look at our final option. Dynamic type substitution is rather easy actually in comparison to the other two. You create a new person name type to hold the person's secondary surname, and then you simply change the type of NIEM core person name to this new type in the instance document, saying in effect, hey, don't use NIEM course person name type for this element, instead use our new person name type that we made that contains a secondary surname. And it does that in the instance document. You can do that in instance documents. Let's take a look at it. Dynamic type substitution results in the cleanest schema we've seen for this yet. We just have our new Iberian person name type based on NIEM core person name type, adding our secondary surname, and then we have our element that makes our new person secondary surname element of person name text type. And that's all there is. The tricky stuff happens in the instance document. Here's what the instance document looks like for dynamic type substitution. Here we see we have our person name, and it's still a NIEM core person name. We didn't make a new person name. We did make a new Iberian person name type though, and that's this little XSI : type equals, and then there is our new type name that we made, the Iberian person name type. This suddenly, in the instance document, changes the type for person name into a different type. It's no longer person name type, it's now Iberian person name type, which means it can now hold our extension at the bottom there, person secondary surname. So, ta-da! We only have one actual extended element in this instance document. So does that mean this one is best? In some cases, sure, but in other cases, not so much, because there's a couple of problems. Problem number one is dynamic type substitution in instance documents is not always well supported, so you might be in an environment that just doesn't do that. But the other problem is that there is nothing in the schema that tells us this is going to happen. There isn't. Let's take a look back at that schema. Take a close look at this schema. There is nothing in this chunk of schema that tells us that we're going to change the type of person name in an instance document to Iberian person name type. Maybe we can infer it being human beings and using human judgment and say, well, why are we making this Iberian person name type? Well, I guess we're going to substitute it somewhere. I mean, you can make that inference if you think about it hard, but the problem is when people define information exchanges, they do it based on the schema. The schema is a set of rules for how an instance document is going to look. And when you use dynamic type substitution, you're basically saying, aha, at essentially runtime, oh, we're not going to follow exactly what the schema says. No, we're going to do this a little bit differently. And the problem is, if you're just looking at the schema and defining information exchanges based on that, you're going to get a nasty surprise at runtime when you start getting instance documents that are changing types on the fly. So there are a lot of limitations and caveats to using dynamic type substitution. So I said earlier, compare and contrast, right? And we've gone through all three. Here's a nice little table really comparing and contrasting them all. And we've got 7 different things to look at, and how does each method stack up under those? Web services is a common way to exchange information, and so it's a natural fit for the NIEM. So let's look at the 3 different ways. Implied substitution groups, they work really well in web services. So does concrete extension. Dynamic type substitution doesn't though, because web services requires everything be defined in that schema, and dynamic type substitution just doesn't do that. It plays tricks in the instance document, so it doesn't work in web services. It's related to our second point there. Is everything defined in schema? For implied substitution groups in concrete extension, yes, everything's defined in the schema. But again, dynamic type substitution, not so much. It doesn't define everything in the schema. Some things happen in the instance document, and that's a surprise. Readability, which ones are the easiest to look at and get the gist? Well, implied substitution groups in concrete type extension are moderately readable because you've got everything in the schema. Now, they might be a little more readable if we didn't have everything global like the NIEM does, and there are reasons the NIEM does that. We've talked about that earlier. NIEM schemas can be hard to read, but still you can read and see what's going to happen. Again, with dynamic type substitution, because things happen that aren't defined in the schema, knowing what's going to happen is difficult. They're not very readable. Implementation level of effort. Well, implied substitution groups are easy. Dynamic type substitution are easy, and you saw that from the preceding slides. It showed just how quickly you could swap these things in and out. Concrete type extension can be difficult. How difficult? Depends on how deep you're trying to stick something. If your thing is 8 levels deep, you're going to be redefining an awful lot of types and making a lot of new elements, and that makes implementation harder. Ease of validation. Implied substitution groups and concrete type extension are both easy to validate because, again, everything's defined in schema. Dynamic type substitution, a lot more difficult because you're not exactly sure what's going to happen in the instance document. How many elements in the local namespace? How many elements do you need to make? Well, implied substitution group and dynamic type substitution have the fewest number, and actually dynamic type substitution has just 1 less than applied substitution, whereas concrete extension can have a lot of new elements in the local namespace. Then finally, semantic precision. And by semantic precision, we mean, are we changing things because they're truly different, or are we changing things for other reasons? Do we have new elements and they aren't representing new concepts? Implied substitution groups and dynamic type substitution are really good at semantic precision because you don't have to redefine much in the way of new stuff. But concrete type substitution has a lot of problems with semantic precision. I mean, think about it for a minute. The secondary surname concept is an Iberian concept. Okay, so fine, I can think of an Iberian secondary surname as making sense. Person name. Okay, it still makes some sense. We got to make a new Iberian person name to hold the Iberian secondary surname. So I can kind of conceptually see semantic precision in a Iberian person name. But now in concrete type substitution, that means we're also going to make an Iberian person, basically, to hold the Iberian name. Well, is that really semantically precise? The fact that you have a secondary surname, now there may be real cultural deals about being an Iberian person, but just in terms of the secondary surname, does that mean that now we have a special Iberian person? In concrete type substitution, you're kind of saying you do. Well, now what if that's inside of something else? What if that's inside of some sort of citation? I'm just picking this out of my ear. Some sort of citation. Well, now if the citation has to be redefined to hold an Iberian person, does that mean now we have a special Iberian citation simply because the person in the citation has a secondary surname? And now we're not very semantically precise. And the more levels we go up, the worse the problem gets. So when you look at all these and you look at this whole matrix, and keeping in mind that a lot of these are all kind of related to how much is defined in the schema and how much isn't, you see that applied substitution group pretty much comes up on top. It really doesn't trail in any of the categories, and it doesn't have any of the big caveats. The only big caveat to it is that there are development environments that don't support it. But that's becoming rare these days as XML becomes more and more of a mature technology. You don't find that's a problem much anymore. But these are the 3 different methods for getting your extensions to fit inside of existing NIEM objects. Finally, tools can help with extending the NIEM. You can use any XML editing tool. You can even use a plain old text editor. Really, XML is plain text. If you want to use a plain old text editor, you can. But any XML schema-aware editor will help in extending. It'll help make sure you do it right, make sure you use the right tags, that kind of stuff. There's a small tool called Extension Wizard, which aids in making extensions for smaller projects. I mention it partially because I wrote it. And it lets you pick and choose, make your containers, add things to it, and then generates the XML schema for you. There are also other development tools that can help hide the complexity of extending and indeed hide the complexity of the NIEM itself. Demoing or even listing all of these development tools is well beyond the scope of these materials, but they're out there. You can find them generally starting at NIEM.gov. And with that, we've reached the end of NIEM Advanced Technical Concepts. By this time now, you should understand most of the technical issues that underpin the NIEM, that make the NIEM work, and how those different concepts are done in XML schema. Finally, a little licensing information about these materials. These materials are licensed under a Creative Commons license. What that means is that you can take these materials and distribute them yourself, or you can use them as a base for making derivative works. There are, however, 2 limitations involved. Limitation number 1 is that if you do distribute these works, you have to distribute them under a license identical to the one I'm showing you right now. And if you want more information about it, there's a URL on the screen. So if you distribute the works, you have to keep the Creative Commons license on them. The reason for that is that it ensures that other people can then take your work and do more stuff with it. These materials go back well over a decade in their original form, and they have been modified and enhanced throughout the years because this license protects the ability to do that, so it's very important. The second part of it is attribution. You need to give credit to the original authors of the work that you're using. So in this case, we're going to give credit to the various works that this work is based upon, and that's in the next slide. This particular work was funded by a grant from OJJDP, the Office of Juvenile Justice and Delinquency Prevention. They're based upon other prior works, partially work done by the Department of Homeland Security under their own grant, and partially under work done over the years by the IJIS Institute, the National Center for State Courts, and the Georgia Tech Research Institute. These materials are a combination of all those prior works modified and enhanced for the Children, Youth, and Family Services community.